Hey, hello guys, welcome, vanakkam, vandanam, namaskaram. Today we are going to see part 3, I think. I don't know which part it is. Okay, so part 3 of electrochemistry. Electric current. Just now I completed electrochemistry, so it's coming to my mind as electrochemistry itself. We are going to see current electricity. Okay, current electricity. So we have completed about conventional current, we have completed about basing, we have completed about types of materials, we have completed about what is electric current, we have completed about ampere, like SI units, electromotive force, drift velocity, okay, all of those things we have completed. And now we have come here, okay, drift velocity's derivation with last part when we have completed. Now in the part 3 we are going to see about the relation between resistivity, resistance, conductivity, conductance, and also we are going to just see this small relation. Okay, see, if you can just remember in the last video itself, okay, where I would have actually written all these big derivations. Okay, so in this only from this only we have got this formula, okay, where A is equal to we know that force is equal to mass into acceleration, force is equal to E into Q. Okay, so mass into acceleration, so that means at last A is equal to E by M is equal to A, where Q can be written as E. Okay, that in the first video when I've said, right? Okay, so that means from this we can get this formula where this acceleration, this total thing will be a constant. Okay, it will be a constant. Okay, and so that means that means drift velocity is directly proportional to not torque. It is directly proportional to the average time. Okay, average time, or also known as drift time. Okay, or it is also known as relaxation time. It's also known as relaxation time. Fine. Okay, it is the time period that is required to hit an electron. Okay, there will be some time period, right? That is what it is. Okay, so that means drift velocity is also directly proportional to acceleration. Okay, also if you are taking this as constant, then that means it will be also directly proportional to acceleration. If you're taking this as constant now, then this you can say it is directly proportional to acceleration. Now we are plotting a graph between drift velocity and acceleration. This is how the graph is going to be. Okay, then the next thing is that Ohm's law. Sorry, I wasn't able to film video when I was writing all these big derivations. Don't worry, only a few only I've written. Okay, very few only I've written. So after completion of that, we'll be checking them very clearly. Okay, so Ohm's law. See, Ohm's law is applicable only with these two conditions, where it has to be in constant temperature and it has to be in constant strain. When these two are applicable, then the current that is flowing through the conductor is directly proportional to the potential difference if it is in constant temperature and if it is in the constant strain. Okay, constant strain. Okay, so if they are asking in 2 marks, okay, in 2 marks, then you have to write like this: the current that is flowing across the conductor is directly proportional to the potential difference if it is in constant temperature and if it is in constant strain. Okay, from morning, this is my 3rd video. Maybe for many of you guys, you can say it's just the 3rd video, just for 3 hours you are taking video, but for 3 hours taking videos is such a big deal for me. Okay, so constant, and it's not exactly 3 hours, it's more than 3 hours. I have to little bit edit, right? For 5 minutes I have to edit. Yeah, 5 minutes only editing. Then I also have to prepare, I have some other works. But today I don't think I was that much productive, but comparatively with other Sundays I'm productive only. Okay, so where for 2 marks you can write like this relation. From our class 10th we are studying like this only, right? So where V is actually voltage is directly proportional to current, so V is equal to IR. So where R is the resistance, so R is equal to V by I. Venkatesh Iyer, that is what normally I say, or vegetarians are Iyers. Okay, so resistance is equal to V by I. Okay, so after this, coming to here, okay, fun learning, we can say fun learning. So these two are actually fun factor, this is fun learning. In fun learning, in Tamil there is a word called veed. Neevider, like that there is neevider. That means you just leave. Neevider, just okay. For me it's paining, hand is paining. So please give me push and pull. That means like this. Okay, it's hand painting. So that is what in Tamil that word is actually needi vida, that we will say. Okay, or there is also another word called as nai vida. Nai vida means house of the dog, dog's house. Okay, kennel we will be saying it as. Okay, so that is what here. So what you have to remember is that J is equal to nee vida. Okay, J is equal to nee vida. I is equal to nai vida. Like that you can remember. So J is equal to nee vida, I is equal to nai vida. In my mother tongue we use that word. Comment in comment section in what way you will be saying. Okay, so the mnemonics that you use, you can say, or you can also, yeah, it's enough. Next note point is that voltage is equal to L is the length. Okay, L is the distance that you have to remember. L is the distance. So voltage is equal to electric current into distance. So distance can be represented as also L, right? So voltage is equal to EL. So there is electric eel. I don't know how many of you guys have seen electric eel in your life. I haven't seen. So electric eels are having the capability to produce electricity. Okay, voltage they can produce. So that is what electric eel is equal to voltage. Like that you can say eel is equal to voltage. Like that you can write it as. Okay. So next is here proving. See, for 2 marks I can prove like this and you can just go. But for 3 marks at all, if they are asking now, you cannot just write like that. We have to do some hard work. That is, see, I is equal to nai vida. I is equal to nai vida, we know, right? Okay, so in place of A, so yeah, in place of VD, what you have to do is you have to substitute the value. You have to substitute these values. See, I don't think so. I would have given you how I is equal to nai vida came. I will give. Okay, I will also say that how I is equal to 9. Now I cannot say. In this video we will be discussing how it came very easy definition only. But for that one concept we want to know. For I we need not to know that concept, but for J we want. Okay, so J is equal to nee vida, right? So for that one we want one concept. So after completing all those written slides, I will be saying like how this I is equal to nai vida and how J is equal to nee vida. Okay, so I is equal to NAEVD. Okay, so here we can give to this VD the value or the formula that is given to VD normally. Okay, that one we have proved in our last part 2. Okay, so that one you can give. If you are giving that one, then at last you'll be getting this formula, that is I is equal to NE square T to V whole divided by ML. So if you're just taking it out, E and E will be multiplied. Okay, so here, okay, this formula, so here this E is there, right? For this E is there, right? So with this E, they have substituted this V is equal to V by L, like that they have substituted, then they have got this one. Okay, then when they have got this formula, okay, you can either start with this formula or you can come to this formula. It depends upon the question that they are asking. Okay, and at last V is equal to IR. Okay, V is equal to IR, that is something we know. See here, this total formula, this NAE square tau divided by ML is there, right? So this total formula NAE square tau by ML is actually equal to R. Okay, this is actually equal to R. So that means if you are writing over here R, then that means that it is actually V is equal to IR. Okay, so how can we say that NAE square tau whole divided by ML is actually equal to R? How can we say like that? How? See, R is equal to ML E square tau R. Yeah, see here actually it is not equal. MR, it is equal to 1 by R. It is equal to 1 by R. Only ML whole divided by NAE square tau is equal to R. This is equal to actually conductance, not resistance. Here it is actually equal to conductance. Here it is equal to resistance. Okay, pakka all and right. So how? Resistance is equal to ML whole divided by E square tau A E. Okay, E square tau NA. Okay, E square tau NA. Tan E square you can take. TAN E square. Okay, like that you can take. So ML by tan E square. We know that VD is equal to E by M into tau, that we know, right? Okay, so I is equal to N nai vida. So from that I is equal to, if you just substitute like this, it will be coming. So like this only we say that they have said that I is equal to V, yeah, like this only we said that it is equal to R, right? Okay. So this total term is equal to 1 by R we said, right? So the same thing is what here also is there. The thing is that we have multiplied and we have taken V alone out. Well, you have to substitute also E over here. If you substitute E's value, then you can take V out, and then the remaining terms will be actually equal to resistance. Like that also you can take it. Okay, but we have stopped it with here even. We have stopped it with V I is equal to N A E square E T tau whole divided by M. Like that even we have stopped it. Okay, don't think that I have remembered all these formulas just by looking at there with my writing remembrance. I'm writing. Okay. So here we can also write that R is equal to, okay, so that means R is equal to voltage, how? R is equal to V by I, yeah, okay, so yes, so R is equal to V by I, right? So I have got this currents formula, okay, so this I's formula we have got. So here this in place of I have substituted this formula. So in place of I have substituted this formula. So that means R is equal to V whole divided by N A E square V tau whole divided by LM. Okay, in place of V also I have substituted voltage by length. Okay, so I have substituted this one. So this V and this V can be cancelled out. Then if you just cancel them, then at last you'll be getting that R resistance equal to LM whole divided by NA E square 2M. Sorry, 2, just 2. Okay, so tan E square. So resistance is equal to ML whole divided by tan E square. You can take it as. Okay, so ML tonic. Okay, so trigonometry, to study trigonometry you will be getting headaches. Okay, so for that you are getting tonics. So tonic by trigonometry. Okay, mnemonics is my creativity brain is creating. Okay, so from this, okay, from this formula R is equal to V by I. So in this one we can also say that there are actually a few. From this we haven't taken this. This is something that we have taken from experiments where resistance is directly proportional to length and resistance is inversely proportional to area, and resistance is actually so if you just combine these two, then you will be getting this proportionality symbol. That means resistance is proportional to length by area. Okay, so in order to remove this proportionality symbol, you can write it as resistance is equal to rho L by A. Okay. So for remembering purpose, you will just write the formula, okay, of resistance. For my remembering purpose, I will be writing it. Also, you can remember this formula by now. Normally, I heard that somewhere, if you know to sing and if you are singing and reading, the formulas, if you are singing, then you will be getting to your remembrance in a very good way. Okay, so resistance. Okay, so to read trigonometry, we want tonic, which is ML whole divided by tan E square. Okay, tan E square. Okay, so since I have discussed about all these elements, you might have doubt about what is N. Okay, what is N in here? I will be saying what is A over there. I will be saying what is L over there. That I have said. What is M over there? I will say, and E square also I will say. Okay, everything I will say. M is mass. That also you would have already known. Tau is actually, yes, yeah. So I will just cancel each terms that if I say, okay, if I say that, I will just cancel them. M is mass that we know. Okay, so mass of that particular total wire we can say, or mass of the particular the total ball we can say, anything. Okay, mostly wire mass, so that's why I say wire. L is the length of that wire we can say. Okay, or the cross sectional length also we can say. Okay, tau is the relaxation period, okay, of electrons. Okay, if there is an electron, there is another electron, and this electron is hitting there, then that means there will be some time, right? The time gap that is between these two electrons to hit one another, right? So that time gap is what known as tau, we can say. Then A is the area. Okay, so A is the area. So from where did we get it? Even from Naive formula, if you know, then we will say. Okay, so N, if I explain here now, you will not come to know. So later we will be explaining N alone. Okay, N alone we will just. Okay, then E square. So what's E square? E square is the charge of that particular electron. Okay, so you can say that it is actually charge of that particular electron or the charge of the particle also you can take. Okay, so it is just Q. It's not, yeah, it is actually E maybe. You can take it as E or you can take it as also Q. Okay. Next is wire gets stretched. So what will we do if a wire gets stretched? See, wire is equal to when a wire gets stretched, there are two different ways. Wire either can be stretched in x-axis way, or wire either can be stretched in y-axis way. There are two different ways, right? Okay, pakka, all them, right? Super, amazing. So R is equal to rho L by A is a formula that we know. So since if it is being stretched by length na, then you have to multiply length. If it is being stretched by area na, then you have to multiply area like this. Okay. So length by length, like that only you have to multiply. If you are multiplying just length na, then that will be giving you some other meaning. Okay. So do not multiply just L. Okay, so length by length is there. So that means rho L square whole divided by area into length. So we always know that area into length is actually volume. If you don't know, now it is a time to know. So area into length is actually volume. Okay, so that means resistance is directly proportional to L square. So resistance is directly proportional to L square. That means R1. Okay, see, that means here, when will you be using this formula? That's a common question you might have. There is, this I will be erasing since I'm not that good in drawing in like rough works. Okay, this is actually this wire. Okay, it was like this. Okay, since this wire's elasticity or the flexibility is actually this very big. Okay, like my flexibility. Okay, so like that, it's very big. So you can take that as this is the same wire but in the second condition. Okay, so here this is actually having R1 resistance and also it is having L1 length. Okay, now this wire is actually having R2 resistance. It will have R2 resistance and then L2 length. Okay, so in this case, now they would have given you what's R1, what is L1, but they wouldn't have given you what's L2. Okay, but they would have also given you R2. In that case, you can use this formula, but do not forget to put L square over there. L square is very important. Next is in terms of area. In terms of area, if I just expanding. For an example, there is this wire like this. Okay, now I'm expanded that in terms of area only. Like this I've expanded. Okay, so in terms of area I'm expanding. So in terms of area, if I'm expanding now, so area by area. So that means here top. Okay, to the top only volume will be coming, and to the down area square will be coming. So that means resistance is actually inversely proportional. Okay, inversely proportional to area square. Okay, this one will write in different color. Okay, so resistance is inversely proportional to A square. Okay, so that means R1 whole divided by R2 is equal to A2 square whole divided by A1 square. Okay, see, I've written oppositely. Okay, like this. So you can also say this as L1 square whole divided by L2 square, like this you can say, but since this relation is already here I've given it, so here I'm not going to write it. Okay, I'll just erase it. Okay, perfect, super, amazing. I'm even appreciating myself. How good it is. Okay. See, since many of you guys may have not seen all these parts, so we will just discuss these formulas. So Q is equal to NE. First with this, if you just formulas are enough because I cannot discuss all those things. So Q is equal to NE, and instead of Q, you can write here it as with the E. Okay. Then next is here we don't have the formulas only. In place of F is equal to EQ, you can write it as E is equal to F by E. Okay, EQ in place of Q. Okay, F is equal to EQ. In place of Q, you can substitute it with E. Okay, then over here, I is equal to Q by T, Q is equal to IT company. Okay, so if you are having the potential, if you are having the charge, okay, that means if you are having the energy, you can work in IT company. Okay, so Q is equal to in place of varying time. Okay, with varying time. For an example, time is varying. Okay, and also charge is varying with that time. Okay, so this is at all very not that much clearly, but somehow I've said. Okay, you can just check it out. Next is instantaneous current is there. For this is the formula where you are going to use limit. Limit is a very important concept of class 11th. If you haven't seen it, I have not uploaded any videos and I'm not in the mood of uploading any videos. Some doubts even I have. I'm not in the level of teaching, but I can do some that alone I'm comfortable with. Okay, next is these are those characters, and here this formula is something that we have studied in 11th itself, where A vector plus B vector is equal to root over A square plus B square plus 2, like this one. Okay, cos theta, not sin theta, always remember cos theta. Okay, then after this ampere, so where 1 coulomb of charge is flowing through per second through any cross section of a conductor, like this it is there. Okay, so I is equal to NE by T, where I is equal to Q by T is there, right? So in place of Q we have substituted NE, then Then electromotive force, so where voltage is equal to work done by charge. Yeah, this is very important. Voltage is equal to work done by charge. VQ is equal to W. V the Q is equal to W. For an example, here also I've got one. Okay, mnemonics. That's I'm an environmentalist. Personally, I love environment, and I'm in the video of uploading one for global warming, all these problems. Okay, so in this concept, VQ, Q means what? A line, right? A line of people where people are standing in a line and they're waiting for something in order to get something. Yes, right? So that is what Q is. So VQ means we can assume that Q is a group of people. Okay, so VQ is equal to what? That means we people, we everyone. Okay, every people in this planet tries just small 1% of step in order to get improved with our natural conditions. Then in that case there will be a work done that we all have to do some work done. Then automatically the world will be retaining the stage. Okay, world is not a place where you can just use it and you cannot just throw it like that. Okay, it's our mother world, it's our duty to protect it. Okay, so we will try somewhat our level best. Okay, we need not to put plastics everywhere, we need not to just go and pollute everywhere, we need not to waste everything. We will be trying. Okay, we need not to just do unwanted access. Okay, we should not take the freedom that is given by nature as an advantage. Okay, so that's what I'm explaining over here. So VQ is equal to work done. V the Q can do a lot of work done. Okay, next is drift velocity. For drift velocity, this formula is very easy. Drift velocity is equal to what? A into tau. Okay, acceleration into tau. So like this you can say it is because see, force is equal to mass into acceleration, where acceleration is equal to E by m. Okay, all these things is okay. So V1 is equal to U1 plus AT1, V2 is equal to U2 plus AT2, Vn is equal to Un plus ATn. So V average is equal to Vd is equal to V1 plus V2 x on Vn whole divided by n is here. Okay, so V average is this formula. So that means you are going to add this one, all these concepts you are adding. So here, this total concept is actually this total thing is actually 0, because U1 plus U2 plus like this, if you are just adding a till to U1, these initial velocities of electrons will be very less only. Okay, and they will be in a free path. Yeah, free path, I think the name is. Okay, I don't know the exact name. Free pathway, something. Random motion of electrons. Yeah. So random motion of electrons. So because of all those concepts in thermal theory of gases, we should have studied, but 11th standard really I'm saying it's a complete flop for me. Okay, wow. So here it is actually 0, where AT1 plus AT2 plus x on ATn whole divided by n. So it's actually A, which is T1 plus T2 plus T3 x on till Tn. Okay, divided by n. Here this particular T1 plus T2 plus x on Tn whole divided by n is actually tau. Okay, is actually tau. Next is Vd is equal to capital E small e whole divided by m into tau. Okay, so from this formula we have got this formula, from this formula we have got these relations that we are discussing. Okay, at last, okay, where we have come to know that resistance is equal to ml by tan E square. Okay, so one remedy, okay, in order to not to like see normally okay, so here is the place where you have to concentrate a lot. One remedy in order to get better with trigonometry is to watch the videos that I'm about to post. Okay, then you need not to drink any tonics. Sometimes self-promoting is good. Okay, then yeah, I'm using the word okay a lot, but it's okay. Next is so after this we will be coming with conductance. In chemistry, electrochemistry, we have to read about conductance. Here also we have to read about conductance. Conductance is everywhere. So what does it actually mean? What is this conductance? Conductance is actually the reciprocal of resistance. Is the reciprocal of resistance, actually, which means that if R is equal to 1 by C, conductance is actually written with this capital C. okay, is equal to capital C. So where R is equal to 1 by C. So that means if R is equal to ml, R is equal to ml whole divided by tan E square. Okay, tan E square, that means conductance is equal to tan E square whole divided by ml. Okay. This is what the conductance is in simple words. So, sorry, it's represented by G. OMG. It's represented by G. It's represented by G. It's represented by G. OMG. Okay. So we can say its dimensional formula is going to be ohm or mho. Okay, its SI unit. Sorry, its SI unit is actually ohm or mho. Okay, sorry, ohm inverse or MHO. Just write this word like this, okay, in the mirror form. So that means MHO. It will be there, right? Okay, or it's not by. Okay, so yeah, you can say it as like this. So I'll just ohm inverse symbol. Okay, ohm. Actually, it's not ohm. It should not be said as ohm. It should be said as Okay, when it has come to India, when it has come to India, it became omnified. That means a lot of words from European countries, and when they just came to India, they got omnified. That means we just added to that sound. So where has become into ohm because it has got omnified. So if you're just saying daily mantra, it will be really productive, said by Sadhguru. You can follow if you want. Okay, next is resistivity. Resistivity. So what is resistivity? Since all these concepts we have already seen, resistance of a conductor of unit area and unit length. Okay, of unit area. Okay, of unit area and of unit length of a cross section. Okay, so the dimensional formula. So what's the dimensional formula? Dimensional formula is actually m1 l1 l power 3 t to the power of minus 3 and a to the power of minus 2. Okay, dimensional formula at all I will not remember. Okay, for resistance you can take it from here even, right? So where this ml by tan a n e square is there, right? From there we can take now. So then what? Or you can also take it as from r is equal to that v is equal to ir, right? From that formula also we can take. Next is it is actually independent of dimension. Okay, it is actually independent of dimension. Okay, so it's actually independent of dimensions. See, is greater for insulators and less for metals. Yeah, so insulators, for insulators their resistivity value will be always greater than for metals. Okay, resistivity value of metals. So then the next thing is resistivity of an alloy is always greater than the resistivity of their constituent elements. Just hereafter I'll write just rho. Okay, resistivity of an alloy. Okay, alloy is always greater than the resistivity of its constituent elements. Okay, then the next thing is resistivity of an alloy is always greater than the resistivity of its constant elements. See, the filament of the electric bulb is made up of tungsten, which has high melting point. Okay, so bulb's filament is there, right? So it is actually made up of tungsten. What's the spelling by the way? Tungstem, correct. Okay, a tungsten which is having high melting point. Okay, then the next thing is fuse wire. Okay, which is actually having high resistivity, low melting point. Always for fuse wire this is okay, and it is actually made up of 63% of tin. Okay, tin 63% of tin. Okay, and then lead 37%. Okay, lead is 37%. Okay, then what is conductivity? Exact reciprocal of resistivity is what known as conductivity. Okay, next is conductivity. Okay, see, the reciprocal of resistivity is what known as conductivity. Conductivity. See, for insulators, okay, their conductivity is represented by sigma. The sigma. Okay, so for insulators, their conductivity value is 0. Yes, right. So insulators cannot, we know, right? Insulators cannot conduct. Correct. Insulators cannot conduct. So for their conductivity value is 0. Then for conductors, their sigma value is infinite. Okay, is infinite, like for metals. Okay, so here is the place where we have to focus a lot. I is equal to Navier. Okay, so where N is electron density, N is not equal to number of electrons. Here N is electron density. What is electron density? It is actually number of electrons of a conductor per unit volume. If you are taking a conductor, if this is what the conductor is, okay, and you are taking per unit volume, that means 1 meter cube. Okay, So that one you have taken in this conductor. So how many electrons are there in this per meter cube is 10 to the power of 29 will be there. Okay, so that is actually this is a note point that you can take, that is averagely a metal will be containing 10 to the power of 29 electrons per meter cube. Okay, so this is what N is, and the N's formula is small n, which is actually electron density, which is equal to capital N. Here capital N is number of electrons. Okay, so do not write them in a reverse way. So capital N by V. V is volume. Okay, so we know that volume is equal to area into length, right? So I have taken this V in this denominator to this multiplication form. So where N into area into length is equal to number of electrons. Okay. So number of electrons. So that is what it is. Now see, we know that. What do we know? We know that I is equal to Q by T. I is equal to Q by T. Yeah. So Q is equal to capital N E by T. So what is this capital N E? Here capital N is what? Number of electrons. We already know this formula, that Q is equal to capital N into E, where E is 1.6 into 10 to the power of minus 19 coulombs. And if you want the charge of E, that is actually minus, because electron's charge is negative. Proton's charge is positive. It is plus 1.6 into 10 to the power of minus 19 coulombs. Okay, so I is equal to Q by T is equal to Ne by T. So where I is equal to NaLe, where see we know that I. So in this N is there, right? In this N you are substituting this value, which is small n, capital A, small l. So and then you are just substituting in this place this formula, and then you will be getting this equation. We know that drift velocity is equal to length by time. Okay, drift velocity is equal to length by time, which is equal to acceleration into tau. Okay, so yeah, so length by time is equal to drift velocity. So I've just substituted in that place drift velocity. Okay, so I is equal to drift velocity. In this, if you're just taking N is what? N is the area density, electron density. So it is actually a constant. Next is area is also a constant. Next is E, which is also a constant. Drift velocity is something that can change, and also area can change. Okay, area can change. That depends upon the area, but we take no, area will not change. Electron density also will not change, because area is constant. Okay, so one and only change is that drift velocity. So here current is directly proportional to drift velocity. If drift velocity is very high, then the flow of current will be also very high. Okay, now next is we are having J is equal to Neewider. So what does this mean? Yeah, so J is equal to Neewider. So before coming into this concept, we have to know a very small concept, that is current density. Okay, that is current density. Okay, so what is this current density? For this, I'll be taking a page here. Okay, so first what you have to know is current density. Having magnitude, okay, the vector having magnitude equal to the current per unit area. That is what it is actually known as. Okay, so it is defined as this, defined as the vector vector having magnitude equal to the equal to the current per unit area. Okay, so it is defined as the vector having magnitude equal to the current per unit area. Yeah. So the direction of current density is the direction of electric current. Yeah. This is something that you have to note. Don't worry, I will be saying all of these points by explanation. The direction of current density is also represented as J, okay, is equal to, okay, direction of current. Okay, this is also a point that we all know, right? Okay, perfect, pakka, done, super amazing. Now I'm going to explain how does this concept actually work. I'll just reduce the size. I personally feel like the size is very big. Okay, so now we are going to just take a conductor. You are first going to consider a conductor. Okay, so just take a lengthy conductor. It can be in the size. Okay, so I'll be taking in the horizontal view. Now we are having this conductor, right? Perfect. In this, I'm going to take a cross-sectional area. That means, see, the current is actually flowing like this. Okay, so like this current is flowing, we know that conventional current's direction is going to be in this direction, right? Okay, perfect. So electrons are moving like this in this direction. Electrons are moving. We know that one. So current direction is in this direction. Is in this direction. Okay, so I'll just write over here that I's direction is over here. Okay, so perfect. In this, what I'm going to consider is this one cross-sectional area. Okay, so this is that area that I'm going to consider. Okay, so see, in this, first we will be saying about area vector. What is area vector? In Gaussian surface itself, you would have known what is area vector. Any vector quantity, not any vector, okay, a vector quantity which is perpendicular to the area is what known as area vector. For an example, this is what the area is, and if I'm drawing a vector quantity that is perpendicular to this area, then it is known as area vector. Okay, so since it is taken like this, so I have to take a quantity which is actually perpendicular to this area. Okay. It should be a little bit more slanting. Okay, so this is how the area vector is going to be. So let me put B. Since it is a cross-sectional, since this is just a cross-sectional area, we are going to put here dA. Okay, perfect. See, first, what is normally density? What is normally density? Density is actually here. Density. What is density? Mass by volume, right? This is something I'm going to erase. Not that much important. So density is equal to mass by volume. Yes, right. Okay, so here it means here it is normal density, then current density na current density, which is J, right? Okay, so J, that means current per area. Okay, current per area, that is what it means. Okay, so current per area, this is what normally density means. Current density, so it is normally current per area. Okay, so current density, we have seen that the direction of current density is equal to the direction of current. Okay, so here direction of current is like that. That means the current density's direction is also going to be like this finally. Okay, and now I'm going to just consider theta. Okay, so I'm just going to consider theta, and here this is J. Here this is J, which is actually current density. Okay, ma'am. Perfect, Packard, and super. So J is equal to. So J is equal to. I will write it in different colors so that it will be kind of attractive. So J is equal to, which is current density, is equal to, what is normally current density? I have already said, right? It is actually equal to current per area. Okay, so this is what the area vector is. Okay, so this is what the area vector is. Okay, so this is what the area vector is. For some reason, also this is being taken. Okay, so now what we are going to do is, we are just going to take this area vector. Okay, we all know that a vector quantity, since this is a vector quantity, we can resolute it. How can you resolute? You can resolute it in terms of x-axis and then in terms of y-axis, right? Okay, so here, since it is what taken as theta, so here I'm going to take this as theta. Okay, so that in that case, this is actually going to be dA cos theta. Okay, and here this case is actually dA sine theta. Okay, wow, perfect, right? Okay, so see, this is what dA cos theta's direction is like this. Okay, and if you just notice, the J's direction is also like this. So since these two directions are same, so in place of area, okay, so in place of area, which is just area, right? So in place of that, I can substitute that J is equal to I whole divided by dA cos theta. Okay, so dA cos theta is the formula. Okay, wow. So here theta is the angle between this area vector and then this current density. So these are the concepts that you have to know. You have to memorize. So yeah, if you want the units, very simple. You can easily calculate the units. What are the units? First, what is the formula? Just you have to take these two. So for current we are having ampere. Ampere. Then for area we are having meter square, which will be meter to the power of minus 2. Like this only the units are going to be. Okay, ma'am. So if you want to take in terms of dimensional formula, so dimensional formula is going to be very simple. Okay, so it's actually going to be what is it? It is just ampere, right? So it will be taken as ampere when the ampere to the power of 1, and it is meter to the power of minus 2. So meter is actually length, so length to the power of minus 2 is what area vector is. I hope you all can understand what I'm trying to say. If not, please kindly try to ask in the comment section. I will try my level best to solve all your doubts. Okay. Yeah. Next concept is going to be this J is equal to knee leader. So how that J is equal to knee leader? So first we know that this formula, first I is equal to knee leader, we know, right? For this formula even I have not prepared, but I have some thing. Okay, see this area is there, right? That is what the existing is. This is what the required formula is, and this is what the formula that we have. From these two formulas even we can easily get it out. I by A is equal to J, right? I by A is equal to J. Yes, right? We have seen here even that I by A, which is area, so that is equal to J. So from this, if I just take this A to the denominator, then that will be A whole divided by area. I whole divided by area equal to NEVD. Okay, so I by A is equal to J. J is equal to NEVD. Okay, wow. Thing to know. Very simple, right? From this formula you can easily get it out. Next is we have a lot of things to see, but we will just come everything by order. Okay, now we are going to check about here in this place if something is there to explain existence, then we will explain them. Next is we are going to check about the relation between J, sigma and then E, that is electric current. Relation between J, which is current density, then sigma, which is conductivity, and then E, electric current. That is what it actually means. Okay, perfect, done. So relation between J, sigma and E. In this first we are going to take about I is equal to nai meter. This is what a very common formula it seems. We are using that in every formula. Okay, in every expressions, in every derivation we are using this as the mother formula. Okay, so I is equal to nai meter. So from this we can easily take that J is equal to knee meter. Okay, so from Ohm's law, what do we know from Ohm's law? From Ohm's law, V is equal to IR. Okay, so V is equal to IR. We also know that V is equal to I into rho L by A. R is equal to rho L by A. That is also a formula that we all know, right? Okay, so that is what I have written over here. From this we can take that E is equal to, not from this, okay, next formula. This is a formula. So next is E is equal to, we know that for this I am going to take this color. Okay, E is equal to V by D, which is the voltage by distance. Okay, so I can take it as also L. Okay, so which can be written as voltage is equal to, this is even enough for this. Okay, so yeah. Okay, so 1 is equal to 2. In this also, if you are just taking out, it is actually V by I. So what is actually V by I? One second. So we know that, which color did I use? EL is equal to V. Yes, right. So from this we can easily say that EL is equal to, okay, V. So from this we can easily say that V is equal, so this is also V, this is also V. So this is equation 1 if you are taking it as equation 1, and if you are taking it as equation 2, then equation 1 and 2 are equal. Okay, so equation 1 is equal to equation 2. So yeah, I is equal to, I into rho L by A is equal to EL. Yes, right. Okay, so L can be cancelled out. L can be cancelled out. I by A is equal to what? I by A is here I, here J is, IA is there, right, which is equal to J. Okay, so J rho is equal to E. So where J is equal to E by rho. So J is equal to sigma E. So J is equal to sigma E. Okay, so here J is equal to sigma E. Now we are going to take sigma alone. Okay, so what is sigma? What is just a sigma? If we are just taking sigma alone, what will be sigma? What is sigma actually? Sigma is conductivity, right? I'll first note that. Okay, so sigma is conductivity. Perfect, pakka, done, super amazing. So after this, what we are going to have, we are having that J is equal to n square 2E by m. So sigma is here. First we are going to check that sigma is equal to, okay, sigma is equal to n square 2 by m. Okay, so n square 2 by m. How is this actually? That how sigma is equal to n square 2 by m? Even I don't know. Now only we are going to check whether the following formula is correct or not.